Hello, everyone, and welcome back. Today, we are going to explore the concept of variables in Solidity and the concept of variable scope. Whether you are a beginner or looking to refresh your knowledge, this tutorial will provide you with a clear understanding of how variables work in Solidity. Let's get started. First, let's define what variable is. In Solidity, variable acts as a placeholder for data that can be manipulated at runtime, and this means variables allow you to store and change information as your smart contract function. When naming variables in Solidity, there are few rules you need to follow. First, your variable names should not conflict with reserved keyword in Solidity. Second, variables must start with either a letter or underscore. They can include alphanumeric characters and underscore thereafter. Remember, variable names are case sensitive. This means name started with capital N and name started with small n would be considered different variables. Declaring these variables in Solidity is slightly different from other programming language. And as you can see here in the syntax of the declaring variable, you must specify the data type at the first, and then followed by the access modifier, and then we have a variable name. So here in this example, this statement declare public integer variable called int var. Regarding to type of variables, Solidity is a statically typed language. So every variable has a default value based on its type. This means there is no concept of null or undefined. Actually, Solidity supports three types of variables: state variables, local variables, and global variables. But before exploring each type, let's discuss the concept of the variable scope and how it applies to different types of variables in Solidity smart contracts. Understanding variable scope is very important for writing secure and efficient code. What is the variable scope? Variable scope refers to the visibility and accessibility of the variable within a contract. It determines where variable can be accessed from and how they interact with other parts of the contract. As mentioned, Solidity has three main types of the variable scopes: local, state, and global. First, let's talk about the local variable. Local variable exists only within the function they are declared in and are not accessible outside of it. They are used for temporary data. In this example, the contract Solidity var test define a function to declare and initialize the local variables. Here we have var1 and var2, and we have this result, which is the summation of the variable 1 and variable 2, and return the result, which is the sum of the two variables. Also, local variables are declared within a function and are only accessible within that function. As we mentioned, their scope is limited and their lifetime ends when the function execution is completed. In this example, we have double value. Here we have a double value, which is a local variable declared within a getDouble function, and it is used to store the result of a multiplying value by 2 and returned by the function. The double value variable is not accessible outside the getDouble function. Now let's move to talk about the next type, which is state variable. State variables are stored permanently in the blockchain and are declared outside any function. These variables represent the state of the contract. In this example, the contract called Solidity var test initialize the value of unsigned integer state variable using a constructor. Here we have a state variable, which is a public here, and we declare a constructor to initialize the value of this variable. As we mentioned, the state variable are declared at the contract level and represent the contract state of the blockchain. They are stored on Ethereum network and accessible within the entire contract. Here's an example of state variable. In this example, we have a count here. This is the variable count, which is a state variable declared at a contract level. It is initialized to 0 and can be incremented using increment function. And the value of count persists across function call and can be accessed from anywhere within the contract. The last type of variable is the global. Global variable provides information about the blockchain and the transaction probabilities. For instance, as you can see here, we have this contract called test, and we're defining this variable, and we're creating a constructor using this global variable. And in this example, the contract test use the message.sender variable to access the address of the person deploying the contract. So the message.sender will be assigned to the admin, which is the variable. And it's worth mentioning that there are many global variables, some of which are presented in this table. And also regarding to the global variable, it is necessary to mention that they are available through the contract and provide information about blockchain, transaction, and execution context. And also here is some common global variable examples. We have a block.times stamp, which is a global variable that represents the timestamp of the current block, which the transaction is being executed. Also, we have a message.sender, as we see in the previous example, which is the global variable that represents the address of the account that sent the current function call or transaction. It allows you to identify the caller of function and perform action based on the sender's address. It is commonly used for authentication, access control, and tracking the origin function call. Also, we have a message.value, which allows you to access the current function call. Here is an example of using a global variable. In this example, the getSenderValue function retrieve the sender's address using a message.sender and the other value sent with the function call using message.value. So we can say the global variable provides valuable information about the current execution context and allow you to interact with the blockchain, handle payment, and make decision based on the sender and the value of the transaction. It is important to note that the global variables are accessible through the contract and can be read by any function. However, they should be used carefully and with proper validation to ensure the security and integrity of your smart contracts. In addition to different type of variables, Solidity also has variable scope modifiers that determine the visibility and accessibility of the variable. Let's explore each of them. We have a public variable. They are accessible from within the contract and can be accessed from external contract as well. And the Solidity automatically generates a getter function for public state variable. Regarding to private variable, they are only accessible within the contract. They are defined in, and they are not accessible from derived contract or external contracts. In the internal variable, they are accessible within the contract. They are defined in the in and derived contract, and they are not accessible from the external contract. And all variables, public, state, internal, share the same syntax, which is as follows. We have a type, which represents the data type of the variable you are declaring. And then we have the type, which is the visibility modifier, either internal, state, or public. And after that, we have a variable name, which is the name you assign to the variable. Here we have this example that demonstrates a variable scope modifier. In this example, we have a public var can be accessed using automatically generated getter function because it's the public. And we have a private char can only be accessed within the variable scope example function or contract using the getPrivate function. Also, we have internal var can be accessed within variable scope example contract and a derived from or a derived contract. I hope this tutorial has provided you with a clear understanding of variable scope in Solidity. Thank you for watching and happy coding.